54 reads, if sine of theta is equal to 4/5 and pi halves is less than theta, which is less than pi, then tangent of theta equals. So you have to be very careful with this one. And the lesson here is that when you're taking the ACT, you should consider carefully every bit of information that is given. In this case, pi halves less than theta less than pi. This seems to be useless, but it's going to be very relevant to picking the right choice. So let's begin by reminding you what the trig functions stand for. So if we have the unit circle is simply a circle with a radius that is equal to 1. And we inscribe right triangles on it. Say for the 45-degree angle, it would look something like this. So we drop a line that will be perpendicular to this line right here. Okay, so this would be considered the x-axis. And then over here would be considered the y-axis. So all we're doing is we're inscribing a circle on the xy axis. Okay, so it would be this and this. And the radius is 1. There's nothing really important about that. It is, but right now we don't need to get into that. But at the end of the day, we're just raising the hypotenuse a certain angle, and we're going to call this theta. And so if it's laying flat here against the x-axis, you're going to have a 0-degree angle. If you raise it like I did here, this would be approximately a 45-degree angle. This angle right here, and this drawing is approximately 45 degrees. Well, the hypotenuse, which is this radius right here, which is equal to 1, would give us this right triangle, where this is the opposite side and this is the adjacent side. And so we can define the trig functions as sine of theta is equal to the opposite side divided by the hypotenuse. Cosine of the angle theta is going to be equal to the adjacent side over the hypotenuse. And tangent of theta is going to be equal to the opposite divided by the adjacent sides. Again, to this angle theta that I'm drawing here on this right triangle inscribed in the unit circle that is at the center of the xy axis. Confusing? Not really. Just maybe pause the video and try to draw this yourself. And as we move further, maybe things will become clearer. Now, something that happens here is that, say, I want to find what sine of 100 and let's do 135 degrees is equal to. Well, what would that mean? Again, if you're standing here, if this is the 0-degree angle and theta is measured as a radius line that is going to be increased by that angle, well, this is the 45, this is the 90, so all the way here, if we do that, puts us at 135 degrees. So that would be this line right here for the hypotenuse, and then we drop a line perpendicular to the x-axis. So now we have if this again is the angle, we have the opposite side, the adjacent side, and the hypotenuse. Now, you may be wondering, well, the angle is this outside angle of 135. True, but again, we're always considering this interior angle that is formed between the adjacent and the hypotenuse as the angle that we're using in trig functions. And so for sine of 135, it's the reason why we would call this the opposite side and this the adjacent side and this the hypotenuse, of course. Hypotenuse is always a long side. Now, why am I bringing this up? Well, first of all, because for a sine of 145 degrees, we find that both the opposite side is a positive value and the hypotenuse, of course, is always a positive value. But when we measure the, say, cosine of 135 degrees, what happens? Well, this time, for the cosine of 135 degrees, and again, this is the angle of reference for the opposite adjacent sides, the adjacent side, which is this one, notice how it lies. It's this segment right here, and it lies on the x-axis, and it's on the negative side of the x-axis, so the adjacent side is negative. And we're going to divide that by the hypotenuse, which is always positive. So what do we end up with? When you divide a negative by a positive, you get a negative answer. So whatever the cosine of 135 degrees is, we're going to get a negative answer. Look at the choices that you have here on 54. You have 1, 2, 3 negative answers and 2 positive answers. Okay? There's a reason why there's a switch of signs. It's because trig functions can give you both positive and negative answers. So you have to be careful when you try to solve this specific problem. Now I'm using degrees even though the prompt is asking us to use radians, just because I want to review this with degrees, but right now we'll switch to radians. I'll remind you what radians are, and maybe that'll help you understand fully how to solve this. So just a quick recap. If we have the unit circle and we inscribe it on the xy axis, the center at the origin, and we use what's called the unit circle, which means that its radius is equal to 1, we can then inscribe right triangles like this. So this would be an example of a right triangle inscribed in quadrant 1, where this is the hypotenuse, this is the opposite side, this is the adjacent side, and this is the angle we're using. We can say inscribe it like this. So this is the angle, this is the opposite side, adjacent side, hypotenuse, but it can also be in quadrant 3, say like this. Or again, this is the angle, this is the hypotenuse, of course. This would be the adjacent side, and this would be the opposite side. Or on the fourth quadrant, let's say it could be like this. And again, this is the angle theta. The adjacent side would be this one. The opposite side would be this one, and this would be the hypotenuse. And in every case, we need to be careful with, say, the opposite sides and the adjacent sides, because they can be either positive or negative. So how do we know if they're positive or negative? Well, as you know, on the xy axis, anything that is to the right of the y-axis along the x-axis is going to be positive. Anything that is to the left of the y-axis is going to be negative. And then for a vertical line, anything that is above the x-axis is going to be positive. Anything below is going to be negative, which means the following. In quadrant 1, the opposite above the x-axis, the adjacent to the right of the y-axis. So in quadrant 1, the opposite side is positive, the adjacent side is positive. But what about quadrant 2? Well, here, the opposite side is above the x-axis, so the opposite side is positive, but the adjacent side, we saw that earlier, is to the left of the y-axis, so the adjacent side is negative. In quadrant 3, look what happens. We have the adjacent side, which is to the left of the y-axis, so that's also negative. But look at the opposite side is below the x-axis, so the opposite side is also negative. Now, when we go to quadrant 4, the opposite side is going to be negative because, again, it's below the x-axis, but this time the adjacent side has now switched signs and is, again, positive. So these right here are very important signs to consider when we're figuring out the trig functions of angles, when we're figuring out sine, cosine, and tangent of different angles. Because depending on where the right triangle is inscribed, depending on the angle, we're going to end up with a positive or a negative answer. Why does that happen? Well, simply because when we talk about sine of an angle, for example, sine of the angle is always equal to the opposite over the hypotenuse. The hypotenuse is always positive, but because the opposite is going to be positive in quadrants 1 and 2, but negative in quadrants 3 and 4, sine is going to be positive in quadrant 1, positive in quadrant 2, but it's going to be negative in quadrant 3, and it's going to be negative in quadrant 4. Then when we look at cosine of an angle, we know it's the adjacent side over the hypotenuse, which means that in quadrant 1, cosine is going to be positive, but in quadrant 2, cosine is going to be negative. In quadrant 3, cosine, look at the adjacent side, negative, so is going to negative as well. And then in quadrant 4, cosine is going to be positive again. And then finally, tangent of an angle is equal to opposite over adjacent side. So tangent, when you divide two positives in quadrant 1, tangent of an angle is going to be positive in quadrant 1, but then it's going to be negative in quadrant 2, but then it's going to be positive again in quadrant 3. Why? Because both the opposite and the adjacent side are negative in quadrant 3. You divide two negatives, you get a positive, so that's why we would write this. And then finally for quadrant 4, tangent is going to be negative again, because this time it's the opposite that is negative. So a negative divided by a positive is going to give you a negative always. And these things become very relevant because, again, when you look at this prompt, it wants to know what the tangent of the angle is when we're between pi halves, theta, and pi. And I haven't explained radians. I'll do that in a second. But this is going to put your angle in one of the quadrants. So you need to know where it is. Because for tangent, you see how it changes signs. Positive here, negative here, positive here, and negative here on the fourth one. So depending on where the angle is, you'll get... So now let's go over radians. What are radians? Well, there's a very powerful reason why radians exist. But, basically it has to do with calculus and other advanced math topics. Right now we're just going to keep it simple. I'm going to again draw the unit circle. And let me just tell you the difference between degrees and radians. So remember that we always start from the origin to the right on the x-axis. And this would be 0 degrees, right? And then as you go up like this would be when you're perfectly perpendicular to the x-axis, this would be 90 degrees. Then if you kept going all the way halfway around, that would be 180 degrees. And then if you say went 3/4 of the way around the circle, this is 270 degrees. And then if you go full circle like this, you know that you're back at 360 here. You're back where you started, but you've now advanced 360 degrees. So this is degree measurements, angle measurements using degrees. Radians work as follows. Well, instead of using degrees, it's like centigrades and Fahrenheit, different measuring units. Well, the more natural unit, which is radians, works as follows. Again, from the center along the x-axis, we're going to call that 0. 0 what? 0 radians. Radians do not have that little circle above it. That indicates degrees. 0 is just radians, you just write 0 radians, or if you know that you're using radians, you just write the number itself without any units. Now, what happens when you go, say, to the perpendicular line here, what would be a 90-degree angle? Rather than do that one first, let's just go full circle. Full circle in radians means you've moved 2 pi radians. So that's the equivalent. 360 degrees is equivalent to 2 pi radians. Now don't be confused by pi. Remember, pi is simply a number. So if we plug pi here into this 2 times pi, we're going to get a number. And that's all we're doing. We're simply saying that when you do one full turn in the circle, you've advanced about 6.28318 blah 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 radians. And that's just an angle measurement. If you're thinking, why would we use pi, which is irrational and we can never pin it down? Again, there are powerful reasons why irradians make more sense than degrees, but there's no need to get into that right now. Just you have to trust that it is relevant, extremely relevant. Anyways, notice too that with circles, pi is always showing up as a circumference, a radius. You know, it's 2 pi r, the area, etc. So you can kind of instinctively see that using pi as the angle measurement is going to allow for some interesting cancellations and approximations, etc. So again, there are powerful reasons for it. Now, if going full circle is 2 pi radians, clearly going halfway like this, what would be the 180, is half of 2 pi. What's half of 2 pi? The 2's cancel, so you get pi radians. So this is pi radians. The 180 that we use in degrees, 180 degrees, is equivalent to pi radians. Which means that, say, if we go halfway between 0 and pi radians at this perpendicular angle right here, it would be pi divided by 2, so pi half radians. And what about going 3/4 of the way? This one right here. What was a 270 before? Well, think about it. It's pi halves, because you've gone this much, then plus another pi halves, puts you now at this spot right here, plus pi halves again, and that takes you all the way here to this angle that we're trying to measure, okay? So how much is pi halves plus pi halves plus pi halves? Well, 1 pi plus 1 pi plus 1 pi is 3 pi's. And we keep the same denominator. So this is 3 pi half radians. And then, you know, if we do the full circle, we already saw that a full circle, which is what started all, is. So let's recap very quickly here. X, y-axis. Inscribe the unit circle, which has, I think I can do a better job than that. Let me redraw this. Okay, that's a little bit better. Okay, so the unit circle has a radius of 1. Remember that trig functions, depending on where the angle is, so we measure it by raising the radius line, the hypotenuse, measuring it theta angle, and then inscribing a right triangle. So remember that quadrant 1, sine is positive, cosine is positive, tangent is positive. Quadrant 2, so that means if I go all the way, say, to this section right here, and then inscribe the right triangle, that's going to give us a positive sign, it's going to give us a negative sign, and it's going to give us a negative tangent. And then if we go, say, into quadrant 3 here, that's going to give us, and we inscribe the right triangle, it's going to give us a negative sign, it's going to give us a negative cosine, and it's going to give us a positive tangent. And then if we go to quadrant 4, like this, say somewhere around here, and we inscribe a right triangle, it's going to give us, again, a negative sign. It's going to give us a positive cosine this time, and it's going to give us a negative tangent as well. And so these are the signs of the basic trig functions, depending on the quadrant. How do you know which quadrant you're in? Based on the angle. And then remember that, say, with degrees, 0 degrees is here, 90 degrees is here, 180 degrees is here, and then 270 is here. And finally, 360 gets you back to the 0 degree angle as well. But you've gone full circle. So if I ask you what sine of, say, 170, well, 170 would put you here in quadrant 2. It would be somewhere around here. If I ask you what sine of, say, 340, well, that would put you somewhere here in quadrant 4. And so that's how you can, based on the angle, that's how you can determine if the trig function is going to be positive or negative. Now, in this prompt, they're not giving us radians. Degrees, they're giving us radians. And so what we need to do is remember, we've reviewed that say when you start here, this 0 degree angle is equivalent to 0 radians. And then this 90 becomes pi half radians. The 180 is pi radians. The 270 is 3 pi half radians. And then when you go full circle, it's 2 pi radians. Okay? Very important for this prompt. And the difference between radians and degrees is simply the scale. It's like centigrades or Celsius versus Fahrenheit. It's the scale. Inches and centimeters, different scales. So degrees and radians are different scales. But now that we've reviewed that, and we've reviewed trig functions, and we've reviewed the signs depending on where the angle is, on which quadrant, etc., we can now finally solve this problem. So now that we've reviewed all relevant concepts here, let's tackle this one. Sine of theta is 4/5, and pi halves is less than theta, which is less than pi. Then what's the tangent of theta equal to? Well, remember, sine of theta is defined as the opposite side divided by the hypotenuse. Now, they're telling us that in this case, we don't know the angle, but we know that the sine of this angle is 4/5. Now, be careful here. Just know that you should always know this very special right triangle, which is the 3, 4, 5 right triangle. When the hypotenuse is 5, and one of the sides is either 3 or 4, then the other one is 4 or 3. In this case, since the opposite side, and in trig functions, this is always the angle. If the opposite side is 4, which would be this one, then that means that we have that special 3, 4, 5 triangle. If you don't know that, or you can't memorize that, don't worry. Knowing that the opposite side measures 4 and the hypotenuse measures 5, you can easily figure out this x value right here, the adjacent side. And we're going to need it because we want to find the tangent of the angle. And tangent of the angle is defined as the opposite divided by the adjacent side. So we know the opposite, but we don't know the adjacent side. So that's why we need to figure it out. And again, knowing that the hypotenuse is 5 and one of the sides is either 4 or 3, it automatically means you have that special triangle, which is called the 3, 4, 5. And it can be like that, or it could, of course, be the other way, where you have 5 and then 4 and then this 3, of course. Okay, so in this case, we're looking at this one because this is the angle of reference. So we're going to be focusing on that. But again, if you don't know that special relationship or that special triangle, you can still figure it out using the Pythagorean theorem. Remember, x squared in this case plus 4 squared should be equal to 5 squared. The sum of the sides of the squared should be equal to the hypotenuse squared. Well, 4 squared is 16, 5 squared is 25, so that gives us x squared plus 16 is equal to 25. Then you're solving for x, subtract 16 from both sides. X squared is equal to 25 minus 16, which is 9. And then you square root both sides to find what x is equal to, and that gives you plus minus 3. In this case, only the positive answer makes any sense. So x is equal to 3. And there you go, the 3, 4, 5. But if you commit this to memory, then you really wouldn't have to go through all of that. You would just know that you're dealing with a right triangle that measures 3, 4, 5 in terms of its size. So now that you know that you have that triangle specifically, you have the angle. And remember, the trig functions are always defined in terms of the unit circle inscribed on the xy axis, right? The problem is, where do we draw this right triangle? Because we can have a 3, 4, 5 here. We can have a 3, 4, 5 here, quadrant 2. We can have it in quadrant 3, or we can have it in quadrant 4. So where is this specific angle they're giving us? We can't assume that it's right here between, say, in quadrant 1, or that it's in quadrant 2. There's no assumptions. You must use the information given. Or what about, if it's quadrant 3 or it's quadrant 4? So how can we use the information given? Well, take a look at this. One telltale sign, of course, is that if the sign is positive, then it means that it must be either here, quadrant 1, or here, quadrant 2, because we saw that sine will be positive in these quadrants. It'll be negative in quadrants 3 and 4. And so if, even though we don't know the angle, we know that the sine of that angle is positive, it means that it has to be in quadrant 1 or 2. So these would be out of the question in this case, okay? Now, we still need to know if it's in quadrant 1 or quadrant 2, and it's not about guessing. This bit of information here becomes very relevant. So we already saw what radians are. If the angle that they're using here, theta, lies between pi halves and pi, look what this is saying. Pi halves is less than theta. Where's pi halves? Well, pi halves is actually equal to this section right here. And then pi in radians is right here. Now, how do I know that these are radians? Because, again, they're using pi, and it's a telltale sign that given this information and given the prompt that we're talking about radians, and therefore pi halves would be here, this angle, and then pi would be here, this angle. So if theta lies between, pi halves is less than theta, so theta would be somewhere around here, okay? That means that pi halves is less than theta. Yes, it is. And then theta is less than pi. Yes, it is. Theta would be less than pi. So where does that put us? Quadrant 2. Now, if that puts us in quadrant 2, then when we do tangent of an angle, we know that it's going to be negative. Why? Because we saw that in quadrant 1, tangent is positive, but in quadrant 2, the tangent of the angle is going to be negative. Why? Because even though the opposite side, this one right here, is positive, the adjacent side is considered to be negative because, look, it lies to the left of the y-axis. It's along the x-axis, and it's where the negative numbers are found. This would be negative 1 right here, so it's like negative 0.7 or whatever it happens to be at the end of the day. So, given the fact that we know the opposite side measures 4, the adjacent side measures 3, the hypotenuse measures 5, and that we're talking about the angle lying in quadrant 2, we know that this is the right triangle that we're using, and this is theta. And so this would be 5, this would be 4, and this would be 3. And when we look at tangent of an angle, we know that it's equal to opposite over adjacent side. In this case, it's 4 divided by 3. However, because it lies in quadrant 2, we know that the adjacent side is going to be a negative measurement. So it's 4 divided by negative 3. In other words, negative 4/3. So looking at the choices, G is correct. There was a lot of things that we needed to review on this one. Doesn't mean that you would have to do all of that to solve this prompt. It just means that if you know that special right triangle 3, 4, 5, you would quickly be able to determine the measurement of the sides. And then if you look carefully at this and say, okay, so the angle is on quadrant 2, be careful with tangent of an angle there, it's going to be negative, then you could have correctly picked the choice G in this case. As opposed to choice J, which is the simplistic answer, that would be true if this angle had been in quadrant 1 or in quadrant 3. But because the angle is in quadrant 2, and this is what's giving that away, then you know that tangent was going to be negative, which meant that G was the correct choice.